All right, detectives, welcome. Today, we're cracking a classic geometric mystery I like to call the case of the identical triangles. Our mission? To figure out exactly what it takes to prove two shapes are perfect, undeniable copies. Let's start gathering our clues. You see them everywhere, right? Perfect copies, perfect patterns. But when two triangles look identical, how can we be absolutely sure? A good geometry detective knows that looks can be deceiving. We need cold, hard proof. So, our first key piece of evidence is this idea of congruence. You'll see this little symbol here. When two triangles are congruent, it means they are perfect clones. If you could just pick one up and place it right on top of the other, they would match up perfectly, no questions asked. That's the goal of our investigation. Okay, here's our case file for today. First, we'll dig into what identical really means for triangles. Then we'll uncover the 5 key clues that act as our proof. After that, we're going to put those clues to the test with a live case, see what our proof unlocks, and finally, we'll learn how to spot the traps and false clues that can lead a detective astray. So what really makes two triangles congruent? Well, technically, it means all 6 of their matching parts. That's 3 sides and 3 angles are exactly equal. But here's a little detective secret. We have shortcuts. You almost never need to check all 6 pieces of evidence. And that's where our detective's toolkit comes in. Inside, we have 5 incredibly powerful methods, or tests, for proving congruence. If we can just satisfy the rules for one of these, we can definitively say two triangles are clones without having to measure every single part. It's a game changer. And here they are, our 5 essential tools: SSS, SSA, ASA, AAS, and a special one just for right-angled triangles, RHS. Let's open up this toolbox and check them out one by one. Our first clue is probably the most straightforward one: side, 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 or SSS. It's really simple. If you can show that all 3 sides of one triangle have the exact same lengths as the 3 corresponding sides of another triangle, they have to be congruent. There's no other way they can be built. Now look closely at the evidence here. These little markings, or dashes, tell the whole story. The side with 1 dash on the left triangle matches the side with 1 dash on the right. Same thing for the sides with 2 dashes and the sides with 3. We've got 3 sets of matching sides. That's an open and shut case by SSS. Congruence proven, next. Okay, our next tool is side angle side, or SAS. Now the key here, and I mean the real key, is that A in the middle. It means the angle we're looking at has to be the one that's included, or kind of sandwiched right between the 2 sides we know. Its location is absolutely everything. See how the marked angle is literally formed by the 2 marked sides? That is what we mean by an included angle, and it is the only one that works for the SAS test. If we knew about 2 sides and some other angle off in a corner, this piece of evidence would be thrown right out of court. Our third clue, angle side angle, kind of flips the last one around. This time, we need 2 angles and the side that's nestled right in between them to be equal. So here, the evidence is an angle, the side connecting it to another angle, and then that second angle. This ASA combination acts like a lock. It completely fixes the triangle's shape and size. Once those 3 parts match up, all the other parts are literally forced to match as well. Our fourth clue, angle angle side, or AAS, is a very close cousin to ASA, but with a critical twist. This time, the side we know about is not between the 2 angles. Now, here's the secret to why ASAS works. If you know 2 angles in any triangle, you can always figure out the third one, right? Because they all have to add up to 180 degrees. So if you have 2 angles at a non-included side, you secretly also have 2 angles in the included side. It's basically a clever version of the ASA test in disguise. And our final clue is a special tool, and it's only for right-angled triangles. It's called right angle hypotenuse side, or RHS. This one has a very specific checklist you have to follow. For RHS to work, you need 3 things. First, you obviously need a right angle in each triangle. Check. Second, the hypotenuses, that's the longest side, always opposite the right angle, they have to be equal. Check. And third, one other pair of corresponding sides must be equal. If you get all 3 of those, you've cracked the case with RHS. All right, we've gathered our clues, we've examined our tools. Now it's time to put our detective skills to the test and solve a real case. Okay, here's the scene. We've got this 4-sided shape, a quadrilateral, And this diagonal line AC, we're told it bisects, or splits into equal halves, both angle A and angle C. Our mission? Prove that the top triangle ABC is a perfect clone of the bottom triangle AD. Let's examine the evidence, piece by piece. Exhibit A. We are told that angle BAC equals angle DAC. That's our first angle. Exhibit B. The line AC, well, it's a side in both triangles, so of course it's equal to itself. That's our side. Exhibit C. We're also told that angle BCA equals angle DCA. That's our second angle. So what does our evidence spell out? Angle, side, angle. The ASA test confirms it. Triangle ABC is congruent to triangle ADC. Case closed. But wait, the investigation isn't actually over. Proving the triangles are congruent isn't the end of the case. It's the key that unlocks a whole treasure trove of new information. This leads us to the detective's ultimate reward, C.P.C.T. It's a mouthful. It stands for corresponding parts of congruent triangles are congruent. But here's all it really means. Once you've proven two triangles are clones, you automatically know that every part of one matches the corresponding part of the other. So in that case we just solved, we now also know for a fact that side AB must be equal to AD and side CB must be equal to CD. We get that information for free. Now, every good detective knows to watch out for red herrings and false clues. And in geometry, there are two famous traps that look a lot like our congruence tests, but they're fakes. On the left, you've got our 5 trusted tools. On the right, the imposters. First up, AAA. Now, matching all 3 angles proves the triangles have the same shape. We call that similarity, but it tells you nothing about their size. You could have a tiny one and a giant one with the same angles. It's a classic false clue. And the other trap, SSA, is just plain unreliable. You can actually use that same information to create 2 totally different triangles. So trust me, avoid these 2. They might look convincing, but they will sabotage your case every single time. So, there you have it. You're now officially equipped with the 5 forensic tools for proving triangles are identical: SSS, SAS, ASA, AAS, and RHS. You know how to use your findings with CP.C.T, and you know how to spot the imposters. So the only question left is, where are you going to find these congruent shapes hiding out there in plain sight? The investigation is now in your hands.